Hello, in this video I'm going to demonstrate how to set up external logic to represent a switch. So external logic in this version of VitalSim is going to be represented by controllers, just like it was in previous versions of VitalSim, but the main difference is that you can create that external logic from within the application. So let's give that a shot. I'm going to create a new controller called switch. Now I'm going to go to our logic editor and select that controller for editing. So this is a newly created virtual controller. It doesn't have any tags or any equations, so let's give it some. I'm going to create a tag called normal and reverse, and these are going to be outputs or physical states of the switch, where if the switch is in normal position, that tag will be true. If it's in reverse position, that tag will be true. Okay, now I'm going to create inputs to the switch, so I'm going to call them motor normal and motor reverse. And you can think of those as the wires driving the motors, so power signals. So if motor normal is driven and motor reverse is not, eventually the normal state should become true. Now I'm going to create a signal called normal drive and reverse drive. Sorry, I should say a tag called normal drive and reverse drive. And what these are going to be are filtered versions of motor normal and motor reverse. So for example, if motor normal and motor reverse are both true, you're not going to have any net driving force towards either direction. So these are pure inputs, we can't control them. This is going to be motor normal and not motor reverse. Okay, now I'm going to create tags that will become true at the moment that the switch hits its target position. So I'm going to call that arrived normal and arrived reverse. Okay, so this is enough to represent the static state of the switch, but we want it to have some dynamic behavior where when the normal input is true for long enough, it becomes normal position, essentially. So we want a delay for that, so we need a timer. Okay, so I'm going to just bring this timers window up there. All right, so this is the timer creation dialog right here. I'm going to call the timer driving us towards normal delay. I'm going to say there's a 3-second delay on that. The input to that is normal drive, and the output is arrived normal. Now I'm going to create a similar one, call it reverse delay. The enable to that timer is reverse drive, and the output is arrived reverse. So now we have these two timers, and we have these tags, but we have no equations. So let's connect those tags to some equations. Okay, so we're going to let's start by creating an equation for normal drive and reverse drive. So I'll click create to start a new equation in the editor. You can see the valid cells in this equation. So it starts off pretty small, just 2 by 5, but you can add more rows and columns if needed. Okay, so I think the number of rows and columns are okay for the normal drive equation. Let's lay that out. Okay, so what I've set up here is the output variable is this variable and not this variable. So here we're going to be setting normal drive is equal to not motor reverse and motor normal. Okay, so this equation is not going to be active until it's been built or compiled. So I'm going to click build, and you can see it appears there with the name of the output tag. So we've got an equation writing to normal drive, and that's motor normal and not motor reverse. Okay, let's do one more. this is a mistake. It should be motor reverse and not motor normal. Okay, so build. Now we've got two equations writing to normal drive and reverse drive. So now we want an equation. So we've got timers here, and the timers are going to set these tags arrived normal and arrived reverse temporarily true when we hit the end point. But that's not going to set the normal state or the reverse state, and it's not going to cause these states to hold once the motor stops driving, which is a behavior you want to maintain. So that's called latching, and I'll show you how to set that up. So let's create equations to drive the normal and reverse tags. So these equations are going to be a little bit bigger. I'm going to add some columns for them. Oops, I made a mistake here, so I'm just going to do a little correction. We actually want that tag there. This is going to have the effect of causing the normal state to drop or become false if we briefly drive the motor in the opposite direction. So I'll show you how that works. Okay, so now we've got a latching behavior there. Let me just build that. So what this is saying is that if we arrived normal and we're not driving in reverse, then we are in normal position. And if we are already in normal position, we continue to be in normal position. So this will give us that latching behavior where if the motor in the normal direction stops driving, normal state is maintained. Okay, let's set up one more for the reverse direction. Okay, so now we've got all of the equations driving our states. We've got the timers hooked up, so functionally it should be working. Let's create a layout to test that. So I'm going to create a switch that's going to show us what position we are in, and I'm going to create some instantaneous push buttons so we can see the effects of those motor drive signals. Okay, so the reverse position is this one down here. So if the switch is in reverse, you're going to see connectivity going this way. If the switch is in normal position, you're going to see connectivity going this way. So the icon's unconfigured right now. We're not going to see connectivity either way. So let's wire up some inputs to these icons, and we can see the results. So we see the switch has a normal configuration element, and I'm just going to call that switch.normal. You'll notice that some of these properties are duplicated here. That's an error to be fixed, but just ignore that for now. So we've configured this icon's normal and reverse indications. And so now when this switch, when the simulated switch goes to normal position, we should see that indicated here in the icon. Now let's configure these push buttons. So I'm going to configure this one to drive the motor reverse signal, and I'm going to configure this one to drive the motor normal signal. Okay, so let's try it out. So what we are expecting is that if we hold the motor normal signal for 3 seconds, the switch will become normal position. If we hold it for less than 3 seconds, we won't see anything. And once it's in normal position, if we briefly click the reverse drive, we should see it go back to an unknown state. And vice versa for this button. So let's start by normal. Start holding that. 1, 2, 3. There we go. And I reverse and it holds its state. So I can see clicking this doesn't do anything now. Let's just, okay, so now I've driven it out of normal position. It's in an intermediate position, and we can see that just briefly clicking either of them for, up to 3 seconds has no effect. But if you cross 3 seconds, let's try that. 1,000, 2,000, 3,000. There we go. And then we can see clicking this one has no effect, and we'll just drive it back to unknown position. Okay, so that's it. That's how to set up external logic. Now, this is a project we've set up to demonstrate this external logic. There's 2 things you can do at this point. You can export this controller for reuse if you want to use this switch model in other projects, and you just do that with export. You can export it to the desktop. Now, once you've done that, you'll be able to load that file in the future and get all the behavior you see from the tags we created earlier. Now, if you want to export the whole project, you can go Project, Save Project. Now, this export is going to contain that controller as well as this layout within one single file. So if you want to reopen everything we see here in one shot, you can reopen the project. Hopefully that was helpful, and please leave a comment if you have any questions. Thank you.